Alright guys, today we're going to graph cotangents, and you can follow along with me in your notes on page 54. Okay, so graphing cotangents is pretty similar to graphing tangents, which we did yesterday. And the idea is we're going to use some different points, but get kind of a similar looking pattern to the tangent one. And you can notice your cotangent graph looks kind of similar to that tangent graph. Okay, so I'm going to start with my angles that we use: 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay guys, take a second and I want you to fill in the y and x values for each of those points. Now, be careful just because the y is at the top and the x is at the bottom. Okay, so now that we've got that filled in, we're going to go ahead and come up with the points for the graph, which are going to be the cotangent values of these angles, right? So cotangent is x divided by y. And what we'll do is we'll just take these x's and y's and divide them. So this is going to be bottom number divided by the top number. So we're going to have 1 divided by 0 and get undefined. The second one is going to be 1. 0 over 1 is just 0. This will be negative 1. And this one is going to be, again, undefined, okay? Now, key things to remember, guys. We don't have to do these calculations every time now that we've got them set up. And these two lines that are in red are going to be my x and my y values. So now I can make my set of points here that I'm going to use every time, all right? So we can call this x, or we can call this theta, my angle, and it's going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, and now our y values, we'll go with it, undefined, 1, 0, negative 1, undefined. All right, and again, guys, same as before, these 2 points that are undefined are actually my asymptotes. All right, so this is a full cycle of the cotangent graph, and we've found the asymptotes for it. There are 2 of them in each full cycle. Now let's look at this table on the side and see what some of the key features and descriptors of this are. Okay, so the first thing they mention is that the amplitude is undefined. We can see an x-intercept in the middle of our graph. And they mention the period being the distance between 2 consecutive asymptotes, okay? So in this case, the period originally goes from 0 until pi, okay? Now, just so that we have a standard for it, the standard formula for the period, just like for tangents, is pi over b, okay? That will always be your formula, all right? Now, the domain, it says that x is an element where it's a real number except for integer multiples of pi. That's a super fancy way of saying that you are everything except your asymptotes, okay? So you would say x does not equal your asymptotes. And again, the formula for the asymptotes is going to be very straightforward as well. It will always be your first asymptote. And we're going to add to that the period times n, okay? So in this case, it's 0 plus pi n, okay? And we can kind of disregard the 0 part. And that leaves us with just pi n as my asymptotes, right? And so x does not equal pi n for the domain. So I'll just make a note of that. Does not equal pi n. Now that's just the standard form. If we moved it around, it could change a little bit, but that formula is the general formula. All right, now let's try setting up a graph for this. Okay, so let's go ahead and write out the original values that we had on the previous page. So theta and my y values, which is cotangent basically. We're going to say, hey, I've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. And on the right-hand side, we've got undefined, 1, 0, negative 1, and undefined again. All right, great. So from here, we will transform these points using whatever changes are listed in this equation, and we'll be able to come up with our graph. So the first thing they say is, hey, start by identifying the transformations, okay? So going back to those same ideas. So let's start with this 2. That is a vertical stretch by 2. Then we've got that -1 at the end, and that is going to be a vertical shift down 1. Okay, that is in the D position. And finally, we've got that plus pi on the inside. And I know it looks really funky, but it is just saying plus pi. And that is going to end up being a horizontal or a phase shift. And I'm going to say it is pi to the left. Okay. Awesome. So we have 3 transformations on here. So we're going to apply all 3 of those to the points that we already know. Okay, we'll start with the original values for the angles. Theta, 0, pi over 4, pi over 2, 3 pi over 4, and pi. So now, which transformation is going to affect those values? Hopefully, you got that it was the phase shift and that it was going to be pi to the left, which means instead of adding pi, I actually say minus pi. Okay, so I'm going to take all of these numbers and we're going to go ahead and subtract pi from them. So we get negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, and 0. Okay, and I'm going to go ahead and highlight these since we have kind of locked in these as my x values. All right, so on my graph, that's my x coordinates. And now we can go ahead and also do the y coordinates. So I'm going to go ahead and continue my chart over here. So we've got that. Let's take these y values, starting with undefined, then 1, 0, -1, and undefined again. Now, the y transformations are the remaining ones. We're going to start with the stretch because we have to follow PEMDAS rules. So we're going to multiply this by 2 first. So I'm going to take all of these numbers and times 2. So if I multiply those by 2, I'm going to end up getting undefined again, right? Can't do any math to that. 2, 0, -2, and undefined. Guys, anything happening to the undefined stays undefined, all right? And then finally, my last transformation, that's going to be that down 1. So I'm going to subtract 1 from here, okay? So subtracting 1 from here now gives me undefined still, 1, -1, -3, and undefined. Awesome. Let's go ahead and put these together now. Again, I'm going to highlight these. These are going to be my y values now for this. And again, you make the points x, y, right? So for example, this one right here, negative pi, undefined. And that first point is actually an asymptote. Let's go ahead and graph that. All right, how about my next point, negative 3 pi over 4. And that's going to be with 1. All right, so if I come over here, here is pi over 4, pi over 2, and 3 pi over 4. And what we'll do is we'll just kind of estimate where that one is. So we've got right about here at 1. All right, and the next point, negative pi over 2. We've got that at -1. Okay, and that's going to be right about down there. Finally, our fourth point, negative pi over 4, and that's going to be at -3. So right here down at -3, and 0 undefined. So we've got this asymptote here as well, right? So just like with the tangent graph, we just kind of sketch it like it's a cubic. Here's my midpoint, and I'm going to go up like this, and I'm going to come down the other way, and bam, you have your tangent graph. If you wanted to continue this pattern onwards, you could. So you can project out that, hey, my period is pi, so following up, I can sketch another asymptote out here, and I can project another set of points here. Take this point and match it up right here. Take my center point, match it up right here. And then take this third point down here. And we could again sketch another period. Okay. So this one in green is like my second period of this graph. All right. Because the shape continuously repeats itself. All right. So guys, that's graphing tangents in a nutshell. We set up our points just like we did with sine, cosine, and tangent, apply the transformations, and go from there. Okay, let's take 1 second. Let's just see if we can calculate out where our asymptotes are. All right, so I'm going to set this aside for now. And let's just make a note. Look, these 2 points that are undefined, those are going to be my asymptotes, right there and right there. All right. So we could pick either of them as our first one, but preferably 0. That's a nice, easy number. So we're going to do 0 plus the period times n, okay? So we need to figure out what my period is. So do you remember what that formula is going to be? My period is, in this case, pi over b. And we can say, hey, my b value here, do I have a number? No, so it's just going to be 1. So I've got pi over 1, or just pi. So I'm going to say, hey, in my formula right here, we put plus pi times n. And again, that's just the period times n. Okay? And again, the 0 part is kind of irrelevant to us. So the formula for our asymptotes just ends up being pi n in this case. Okay? So that is the formula for my asymptotes. Okay? So we calculated out the period on the left, and then we applied that to help us find where all the asymptotes are. So if you wanted to project out more asymptotes, this formula will let you pick out any number of those that you want. And that's basically graphing in a nutshell, and we threw in some period calculations and asymptote calculations as a little nice bonus there, okay? Remember, this formula for the period is going to be the same for tangents and for cotangents. All right, so as long as we remember this formula, we can always calculate the period no matter what my b value is. And then we can always say, hey, the asymptote is going to be the first one plus the period. Okay, so this is, again, the first asymptote. All right, if you add those together like that, you'll always be able to find the formula for asymptotes there as well. Okay, great job, guys. I hope this video was informative to you guys. Make sure that you practice graphing and calculating periods, as well as calculating the asymptotes and finding the formula for those. I'm sure those will turn up on your homework and also on your test in the future, okay? If you liked this video, please hit the like and subscribe button. Just kidding about that, guys. Don't like and subscribe my channel, but please do your homework and study for your tests in the future.